testing. That's our hypothesis test. And that's the setup. Everyone okay on the setup? Look, I didn't put hats on these. Right? And this is always the null. Alright, everyone, we get to verify our requirements. Let's just verify our requirements. It may look long, but everyone, this is the same thing you've been doing, so have no stress. That's why I didn't have to pass out a document on this. I'm like, they get this now. Remember the n times the p times the q had to be greater than or equal to 10 with proportions? Well, I just have to do two of those. So here I go. I just got to put subscripts of 1s. n sub 1, n p q, greater than or equal to 10. And I will just put subscripts of 1s. That's it. That's for group 1. I have to put hats on these because we don't know the proportion yet, right? No one gave us some proportion out there. There's no like official doctor group that said, here's the proportion that's gonna, experience drowsiness. So we're using the actual sample proportions as an estimate. Oh, I gotta do one for the 2s. Here we go. N sub 2, p hat sub 2, q hat sub 2, greater than or equal to 10. We just gotta check this. Anything else? Oh yeah, do you remember this? Do you remember the sample size has to be less than or equal to 5% of the population size? So let's add that too, okay? N sub 1 has to be less than or equal to 5% of population size 1. N sub 2 has to be less than or equal to 5% of N sub 2. Do not let this bug you. But we do just have to verify this stuff to make sure the distribution that we're going to deal with when you and I go like this, that we're allowed to do this, that this is going to be allowed, that the distribution is approximately normal. That's all. Is this sample size big enough so we can do this stuff? This one, I know we're good to go there. I want to make sure we do that calculation. Because that sample size, everyone, was only 99, right? So I want to make sure that's verified. I haven't checked it yet. We'll just grab these numbers out of the book, but is that number right there times this proportion times 1 minus that? Keep in mind, these q's just means 1 minus the p hat. Always remember that, by me writing that. It just saves so much room. And when it makes it look so much more complicated when you gotta go, p hat 1 minus p hat there. That's all. Alright, can we verify this? This is the only boring part. I'll admit, this is the only boring part. We gotta verify this. Oh, did they say anything about it being random? You remember that? They said it was a randomized, and it was double blind. So if you wanna, that's actually part of the requirements that we're actually saying. We're starting from chapter 1 in this book that, hey, you doing it randomly? And it being double blind is even better. It's a very effective experiment. So, best part of the course are on this stuff. You go, why? You might find yourself doing something like this. Well, it might not be a drug, but I mean something in your field of expertise. I'm being honest. You might find yourself doing something just like this. You report it. Heck, it might be for like your PhD. You'll be doing a dissertation or something. You'll go out and get a sample, another sample. You may find yourself doing this. You won't even have to email me, right? You'll be like, I got his notes. I forgot to do this stuff. I know how to set this stuff up. All right, everyone. This is the one. I'm sure this is good to go. This one too, everyone, we're talking about infants. Don't you have millions of infants? Mm-hmm. So you're going to be less than that. That sample size is definitely less than 5% of millions. Let's make sure this is true. I know this one's going to be good, this one right here. Well, let's just see, that's 99 times, what's the p hat? That'd be what's 31 over 99?
0.3 something like that.
That's about 0.3-ish.
0.31.
It's about a 0.31. And then what's 1 minus 0.31?
0.69.
Like a 0.6. Let's just make sure. I know we rounded those, but it's okay. We just make sure it's higher than 10. Higher than 10? Question mark? Higher, is it?
Yes.
It is? How high?
It's 21.
Oh, see, we're good. It's 21. We're good. And we check it off. Give it a check. This one's good too. 99 is less than 5% of millions. 1 million. 2. If this one's true, this one's definitely true. That's my point. You're like, I know that's good. And that's all we gotta write. That's all we have to put. And it was random, we're good. It was randomized. I'll put that in there. It was randomized. Alright, now we get that fun. But now, is everyone okay with this? We're not gonna sit here and kill ourselves what? it right. We're gonna use the technology to compute this for us. That sound good? That's the idea. Let it facilitate this. We're gonna interpret this. We're gonna go through. I'll get a p-value. There's the outflow. If your p-value is low, reject the hell, right? Okay. We'll make a little left-tailed test here. We'll shade 5% on the left side. This is proportions, everyone, so this is z. So when we do this stuff, this is not t, this will be z. We'll shade it right here. We'll shade that. And if it falls in there, we reject the null hypothesis, right? Cool. So is everyone ready? All right, we're going to do the classical approach. Let's have some fun. And we'll do the p-value approach. Classical approach. Go ahead and draw a bell. I like to put z or minus for doing z. What's z equal to right there?
0.
0, 1, 2, and 3. These are all negatives. What's z equal to over here? This is really all about pictures, though, and that's why I always draw a picture. These hypothesis tests, we got a distribution going on here. Now I'm going to shade 5% for the left side. All right, 5%. I don't know how far to go, Owen, but we'll just shade. %. Not drawing a scale, but it is a left-tailed test, so I do have it shaded on the left. Not drawing the scale, it's not a perfect bell, but definitely finding out. Yellow chalk, so I'm going to drop my white chalk. Yellow chalk. Just like before. Nothing's different. I'm going to find my z crit. I'm going to find my z crit. This is z, so I got to find my critical z score. I know it's going to be negative. Let's talk about technology. How do I get the z crit with technology?
Inverse norm.
Inverse norm. Inverse norm, what percent?
0.05.
Yeah. So if you want to use your technology right now, hit inverse norm 5%. A lot of us are like, we get it off the what?
Chart.
Right, everyone? A lot of us get it off the table, so let's get our tables. Anybody need an extra T table, Z table? Sometimes they get lost, you know? You take a test, you throw it in a trash can or something by accident, like, yeah, go and test. But I have extras here if you need. So you can read it off here. This is a T table. At the very, very bottom, what row do we have? Z. So I'm going to look at this thing. And I'm going to verify. Anybody already hit on a calculator? I'm going to verify with you there, Art, because I know you just typed in inverse norm 5%. And right here, he's typing inverse norm on his calculator 5%. I'm looking on this sheet, and at 5%, it says 1.645.
Mm-hmm.
Now, does anyone know why I'm making it negative? It's on the left side. That's why I made that negative. So you can use your table, or you can use technology to get that. All right, cool. Drop this. Everyone, it's the same story. If look at this thing. If that number falls in here, based on these two proportions, we're going to reject the null hypothesis, right? We'll get a p-value. If my p-value is low, we're going to reject the null. There's no way you can miss unless I accidentally type in the wrong number in my calculator. I'm being serious. Now, I bet you can predict where I go on my menu. So I bet you can find it. So these are proportions, right?
Stat test.
I'll go to stat test.
Mm-hmm.
I'm not doing this by hand unless you want to. What's this for?
I think number 3, this one.
Stat tests. Well, it's a hypothesis test. It's a hypothesis test. But this is for how many proportions?
1,
One proportion. This has
2.
two proportions. So we're going to use two prop z test. Two prop z test. Right? And when you see the setup, you're going to know exactly what to type in. Check this out. It's number 6. So you're okay. In 11.1, I use number 6 every time. True? And I hit it. All right, what goes there? What's the next of 1?
137.
137. What's sense of 1? A 4, 5, 2. All right, what's x of 2?
31.
See, it knows you have all this stuff. You get two proportions. 31 out of 99. Which one do we want?
Less than, right?
Yeah, left tail test. So make sure box. Calculator draw, I like calculating. If my p-value is low, reject the hell, right? That's the first thing I look at. Look at the p-value. Lower than 5%, is it?
No.
Right there.
Way greater.
Way greater. Do not reject the hell. We know the entire answer. My conclusion, there is not sufficient evidence suggesting that the proportions are different. So this drug, kick the Prevnar, it's not going to make them like more drowsy, that's what we're saying. Yeah. They're going to be way more drowsy. Not with that p-value. Is it unusual to get things in this world? There's a 42% chance of something
A
happening.
lot.
It's not unusual, it happens all the time. Right? Right, exactly. Alright. Hey, they gave us some other numbers. Did you notice they gave you a little pool p-hat? Isn't that nice? If you wanted to know what it was. There's that pool p-hat, but it did all the computations for us. So you might even ignore this. There you go, thanks for doing that, but this was really the number I wanted. And that number too. These are the two numbers you want. That one and that one. Here, I'll hit the laser. If it shows up on that camera. I want that number, and I want that number. Those numbers, that's the p-value. That's just p-hat 1, p-hat 2, that's just the pool p-hat. Which allowed us to do all that right there, because it was sitting right there. Thank you, you just saved us a lot of time, right?
So you're just looking for just the P.
You got it. Randy, you're absolutely correct. That's what I wanted. But Randy, let's use that number 2.
Right.
Because we can draw it in our nice bell for the classical approach.
Right.
Cool? All right. Okay. But it's really the p-value. Y'all agree? That's what we concentrate on. So I'm going to hit it. And when I'm going to perform the p-value after I finish the classical approach, and we'll state our conclusion. What was this number again? This is called the...
Z0?
Yep, I always like to write it out in words.
Sample statistic.
Yeah, it's a sample test statistic. That's what it is. It came from our sample. It was that gigantic expression right there. And this number came out to be roughly negative
196.
.196 or negative 0.2. Let's draw it. Boy, did I love it that last test when you all drew this in your bell. I love it. Where is it located?
All the way to the left.
It's about right there, isn't it?
Yeah.
It's like a hair left to the 0 mark, isn't it? It's right off the 0. It's about right here. I like it's like, give it a little, y'all get the Z out of the way. It's right there. There's my Z naught. It's right there. But it's not even close to the what? The rejection region, right? Where you reject. It's called the critical region. But it's not even close to that. All right, there's Z naught. I want to negative 0.196. Right there. P-value approach. This will be quick.
Don't you need to write the conclusion like there is no evidence? Do you have to?
Absolutely, and some of you might have already written it. Art, very good point. Some of you may have already stated your conclusion because you knew it. You knew it right away. I'm gonna write out the p-value expression, then state my conclusion. So Art, very good. You could do it right away. Once you found that p-value, and you saw this number wasn't in this region, right? Hey, my p-value was like 0.42. Yeah. Oh my gosh. And so I'm just going to interpret that on this right here. You go, what is it? It's a probability. It's the probability that, see this number right here? That my test statistic was on the left side of this negative 1.196. So I mean, could you imagine if I shaded from here over? Isn't that a lot covered? Yeah, like 42%. That's what that really is. This came from this. I always wanted you to know, where did the p-value come from? I always want students to know that. You go, what is a p-value? So I always interpret. Every time, I always interpret the p-value. This is the probability of obtaining these statistical results. These statistical results if these are equal. Well, because, I got a period there, because my p-value, hey, you know what and when I put it, obtain these statistical results, some of you may say or more extreme, but I got it written right there. So since I stated it right here, I didn't have to say or more extreme. Because my p-value is it lower or greater than?
Greater
Whoa, yeah, way greater than the what?
alpha level.
This was a 0.42, this was a 0.05. Because it's way greater, what are we doing about the null?
We do not.
We do not reject the null. Sierra says we fail to reject the null. So you can say it either way. We do not reject the null hypothesis. We keep it. Well, we can't write that. We keep it. We can't write that. Why not? It's like saying the person's innocent, right? We just say we find them not guilty. Same thing. We do not reject them. So hey, I'm going to state my conclusion. Conclusion! Boom, boom. There is sufficient evidence, or there is not sufficient evidence. I want to make sure I don't mess this up. This was not in here. We do not reject the null. I'm going to mention this right here. That's what I did this entire test for. I spent a lot of time getting these people in this experiment, all these infants. Took a lot of money too, a lot of time and effort. Well, what's my conclusion? There is not sufficient evidence suggesting you can't use words like prove because it's not literally a math proof. So I don't say proving. Suggest